What?
Yes.
What?
So why do they call
Oh,
it
it's the
calculus if
opposite
it's
of
just
derivative.
Yeah, but it's just a derivative class.
Oh, it's a derivative inverse.
Okay.
Derivative
My
hour.
slate died, so I have to
Oh.
write it here today.
I didn't know it could do that.
I know. I usually charge it. Okay. So I want to talk for a second about. We've done a couple things like to the third
what
power.
is that?
I'm in the middle of talking and explaining. Just hold your comments for a second. I'm telling you what it is. Okay, we've done things where we had like x something to the third power, right? And we wrote it out 3 times and did our product rule. And we found when we had it to the third, we had to do that product rule like derivative of the first, and the other 2 stayed the same. Plus derivative of the second, and the other 2 stayed the same. Derivative of the third, the other 2 stayed the same. So that's what this is saying. U is whatever my thing is. So derivative of the first, the other stayed the same. Derivative of the second, the other stayed the same. Derivative of the third, the other stayed the same. And we figured out that those were 3 identical things, right? So it was 3 terms with a u squared and a u prime. So the derivative. This is, in essence, a chain rule. So it is giving us a shortcut for how to do something. If, for instance, it were
Oh my gosh, that marker is so thick.
2x plus 4 cubed. Alright, if I did this derivative, then the derivative of the first, so if I think of this, the only way we could have done this before today is to write it 3 times, right? That's how we would have done it before. We say, okay, derivative of the first one is 2, the other 2 stay the same. Can I just write it as 2x plus 4 squared? Alright. Plus, now the first and last one stay the same, so we still have a 2x plus 4 squared. Derivative of the second one is 2. Plus, the first and second stay the same.
Should fancy
Derivative
report.
of the last one is 2. And so we get 6 times 2x plus 4 squared. We agree? So that's what this derivative comes out to be. I'm telling you that there is a shorter way of doing this. So, this was to the third power. We know if you have something to a power, the exponent comes down, inside stays the same, subtract 1 from the power, right? But it wasn't just an x on the inside. So what's the derivative of 2x plus 4? And we get 6 times 2x plus 4 squared. So we get the same thing with a fraction of the work. This is what's called the chain rule. Whenever we have a function within a function, so a composition, because I had the x cubed on the outside, I had 2x plus 4 on the inside. Then you can do the derivative by doing derivative of the outside, inside stays the same, times derivative of the inside. So that's the process we are going to be using today. Let's look at one together. So if I asked you to find this derivative. Okay, it's not just x to the 17th, but we can start there. The outside thing is the 17th power. So if you're doing the derivative of something to the 17th, exponent comes down, and you would subtract 1 from the power, right? When you're doing that, the inside stays the same. So we're basically starting with the outside. Derivative of the outside. So that's the 17th power. The inside does not change. Then we have to multiply by the derivative of this inside part. What is the derivative of 3x squared plus 5? And then we can just simplify 17 times 6. So we have 1 or 2x times 3x squared plus 5 to the 16.
Would you not distribute that?
You can't because order of operations, you have to do exponents before you multiply. Way better than writing that original problem 17 times and doing the product rule 17 times. Okay, so the chain rule is a time saver. Just a note, when you see like dy dx, that means derivative. Don't think of it as like a fraction that's canceling out. It means how y changes in terms of x. So how y is changing in terms of x. Alright, let's look at this one. A square root can be written as what? So this function is x squared plus 1 to the 1/2 power. So the derivative, you start on the outside. The outside is the 1/2 power. So exponent comes down. Inside does not change. Subtract 1 from the power. 1/2 minus 1 times derivative of the inside, which is 2x. 1/2 times 2x, which is 2x, times x squared plus 1 to the negative 1/2.
Maybe this is just silly, but why wouldn't you just do the square root?
Because it's more than one term. Just like if it were squared, you would have to write it twice in FOIL. Because you have things added, you can't do the term, or the square root of each individual piece.
I think math is just completely made up. Yes. The cake is a lie.
Just trying.
Oh my gosh, sorry, I'm dumb about it.
Alright, I am doing 2 different derivatives. When you do the chain rule, we start with the outside. On the first one, what is the outside? Sine. So it's the derivative of the outside and the inside doesn't change. The derivative of sine is cosine, and the inside doesn't change. Times, because it's not just an x on the inside. What's the derivative of the inside?
2x.
So we could write that as 2x cosine of x squared. Is that one okay? B. What this means, when you see sine squared x, it's saying you have sine of x to the second power. If we have that, what's the outside?
2.
Second power. So we do the derivative of the outside. So the exponent comes down, inside stays the same. Subtract 1 from the power, so now it's to the first, times derivative of the inside. Okay, or you could just write 2 sine x cosine x. Parentheses aren't needed. Is that okay? So I'm just gonna kind of skip over this because we are really doing doing that already. We don't need to mention it as a separate thing. I just want to talk about this one for a minute. We know a derivative represents a rate of change. So this one says an oil refinery makes U liters of gasoline, so U is the liters, from X barrels of crude oil. Then they make Y grams of petrochemical from the U liters of gasoline. Identify the units of dy du, du dx, and dy dx. Keep in mind, a derivative, it's like the slope of a tangent line. So your units, it's like a slope, something per something. It's a rate of change. So just look at your variables. Y is on top. What were the units on Y? Grams of petrochemicals. So let's just do grams, just units. Per U, which was? So the units of dy du is grams per liter. Do you guys know what the units for du dx would be?
Liters per barrel.
Because y for u is liters, x is barrel. Okay, what about dy dx?
Grams per barrel.
Now we're just going to practice just straightforward chain rule. I want you guys to go ahead and try example 5. If you get done before I start, you can do example 6 as well. All right, so 5,
What? Oh.
we get 100 times x cubed minus 1 to the
99.
99 times what? So we could turn that into 300x squared x cubed minus 1 to the 99.
Was it just one?
Hmm?
Not in reference to that. Never mind.
That's the one first I noticed.
Okay.
All right, is that one good? Number 6. So h prime of x. Start on the outside, so that's a -3. So -3 comes down. Inside stays the same. Subtract 1 from the power, so that one's -4. Times, what's the derivative of the inside?
5x squared minus 2x plus 5.
That's the inside. What's the derivative of it?
Oh, sorry. I was looking at my answer.
As far as simplifying, when you do these chain rules, we're going to end up with a lot of stuff. You can multiply the -3 with this parenthesis. Why can I do it with that one and not the first one? Right, we can't bring it in if it has an exponent. So you could, if you do that, make sure you put this in parentheses because it's the whole thing times this. And that would be our answer. If you left the -3 out, I would not count that wrong. Okay, that is still equivalent. All right.
Why is that 3 so long on something? Got like stretched.
So, example 7. What's the derivative going to be?
Oh, 3.
So start on the outside, inside stays the same. Subtract 1 from the power, times derivative of the inside is, I would like if you multiplied, since it's just two numbers, so -15 times 2 minus 5x. what do I have to do?
As a negative.
You can multiply it out, like write the bottom twice and multiply it out.
Flip it with the negative.
We can do a quotient rule with the chain rule inside it, or we can write it as a negative power. So, 3 different options. Depending on which one you take, your answer will look a little bit different, but as long as you have an equivalent answer, it's correct. Okay, so we're getting into that. We've kind of hit it already, but there's a lot of things that might look different, but are the same answer. And it just depends on how you simplify to begin with. So which route do you guys want to take?
Negative. Everything else stays the same, it just becomes a negative, right?
Yeah,
It goes to the
negative,
top.
excellent. So now we have to do the chain rule. So derivative of the outside, that means the -2 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside is
6x squared minus 1.
you could leave your answer like this. If we multiplied, what things would we multiply together?
The negative 2 and the 6x.
So you could write it as -12x squared plus 2 times 2x cubed minus x plus 7. But if you do that, make sure the -12x squared plus 2 is in parentheses because it's the whole thing being multiplied. Is that okay? Let's do, I'd like to do maybe 9 and 10 if I could,
Oh, yeah.
and then I'll stop for today. Number 9. Can I just get rid of the division this time? No. Okay. We have different options, but let's just go with it as it's written. So if I did this, derivative of the outside, so the 5 comes down, inside stays the same, subtract 1 from the power, so it's now to the 4th.
Interesting.
Times. How do I do the derivative of the
I
inside?
had a quotient rule.
Quotient
I
rule.
tricked myself into thinking it was way easier than that.
Low. D high. What's the derivative of the top?
Z.
1.
Oh, yes, no, you're right.
Minus. High. D low. What's the derivative of the bottom?
1.
Over. Low. Squared. Alright, we definitely need to clean this up a little bit.
I did
This
too.
fraction, what?
I thought it was just gonna be 1. I forgot the quotient rule even existed.
We have, I'm going to split this up and write it as z minus 1 to the 4th and z plus 1 to the 4th. Are you guys okay with that if I take the 4th power to both the top and the bottom?
Yep.
Times. We have z plus 1 minus z minus 1 over z plus 1 squared. If I distribute my negative, the z's cancel and we just get 2. Alright, so one more step, let's finish it. On the top, if I multiply 5 times z minus 1 to the 4th times 2, we get 10 z minus 1 to the 4th. On the bottom, z plus 1 to the 4th and z plus 1 squared, z plus 1 to the 6th. So we can use a combination of rules. We're going to do quotient and chain this time.
Would you take it if we left it as the 10 over z plus 1 squared times the z minus 1 over z plus 1 to the 4th?
I'd probably take off a half
Okay.
for just not combining the similar things.
So, okay, I kind of
He was saying if you left this instead of taking the top and bottom to the fourth, so that we could, so if you
So
left,
if I left it as 10 over z plus 1 squared and then the other fraction,
Mhm.
you would take off a half.
Yeah, just because these are the same on the denominator, so I'd like it if you recognize that and put them together.
Okay.
Sound okay? Last problem of the day.
Am I gonna have to product rule?
We have to do product rule. Okay. We have two things. We have this one. We have this one. So if they're being multiplied, we have to do product rule. Derivative of the first one. How would I do the derivative of an x plus x squared to the fifth?
Pull the 5 out, push to the chain.
Alright, so 5, inside stays the same, subtract 1 from the power. Derivative of the inside,
2x plus 1.
okay, you guys okay, that purple is just the derivative of the first piece. So chain rule is the derivative of the first times the second for our product, plus the first times derivative of the second one. Okay, how would I do the derivative of the second one?
Pull the 2 out.
2 comes down, inside stays the same, subtract 1 from the power, so it's now the first, times derivative of the inside,
3x squared.
okay. For simplifying, there's a lot that you can do, a lot of different ways you can do it. Let's just go with the basics. In the first term, what could I multiply together? Can I multiply anything together in this first?
I mean,
No.
well, yeah, you could.
Oh.
1 plus 2x and 5.
Yeah, I'm not gonna count it wrong if you don't. Okay, but if you were going to multiply anything, those would be the things, because the 1 plus 2x doesn't have an exponent. So you could choose to write that as 5 plus 10x. If you didn't, it's not wrong. But the second term, there is something I would want you to do.
Distribute the 2 and then multiply with the 3.
Yeah, at the very least, I would expect you to say 2 times 3x squared is 6x squared. Now, you could also multiply that with 1 plus x cubed, but again, if you don't, I'm not gonna count it wrong. But if you don't even multiply like just numbers together, I'll probably take off a half. That is like the only simplification that you really have to do.
I'm sorry for whenever you have to grade these.
They are fun. Okay, that's our stopping point for today. We are going to keep working on this. The rest, well, tomorrow, Monday for sure, and probably even after Thanksgiving, we'll still be on it. There is a handout post on Google Classroom that I would like for you